So I wanted to show you that color preference study. So with the toy color and the face, this is the data for that. I have it posted on D2L if you want to use it, but that's not what you're going to use for the activity. So if we look at variable view for this study, they have labels, so we know what the variable names mean, and then they have the values. So 1 is red, 2 is green, and 3 is gray, and 1 is happy and 2 is angry. To run a chi-square, you're going to go to Analyze, Descriptive Statistics, Crosstabs. So then we're going to put our IV in the rows, which was face, expression of the face, and our DV is in the column, color of the toy. Then we click the statistics button and click chi-square and click continue. Here also in the statistics is the kappa and some other things that we're not going to use. The McNamara would be here if you ever wanted to do it in SPSS in the future. It's in this statistics box, but we'll only use the chi-square. Then we want to click in the cell box. We want the observed counts. That means the counts that were actually seen in our data. We could show our expected counts if we wanted to see that, but I think that makes it look too cluttered, so we're not going to use expected counts. Then we want the percentages of the columns. So that's going to be like that table we looked at that has the percentages for each box category. So we'll check off column and then leave everything else the way it is. Press continue, and then we press OK. Oops. So then this looks very similar to what I showed you on the PowerPoint. We have the case processing summary, which has the total of 40 in our sample, and there's 0 missing. Then we have, oh, I did it wrong. Whoops. So expression of face should be in the columns, and color of the toy should be in the rows. Sorry. That makes more sense. So here we see the same thing you saw on the PowerPoint. So happy, 15 people that were saw the happy face and chose a red toy. So this is how you calculate the chi-square. It's pretty easy. You just have to go to Analyze, Descriptive Statistics, Crosstabs, put them in, and then go to the statistics. Click it off. So that's a pretty easy one to run in SPSS, right? Thoughts? So that's all you have to do for that. I'm going to hand out this worksheet that we're going to go through, and we'll do the first one together because it's entering data into SPSS to use the chi-square, which is something you will have to do in your homework. And then I'll let you work on the rest of it by yourself. And if you have questions, I'll come around and help you with it. Okay? Sound good? You can work together too. I'm not going to, and I'm not collecting this. This is just for you to practice so you can ask questions while I'm here, so that if you have questions, you know what you're doing. For your homework, especially. And this is also posted on D2L if you want to do it on humans. We're going to review the first one. Yep. All right, so before you start, we're going to do this first question together so you know how to enter the data the right way. So we're going to open SPSS, open a blank file, blank data file, which is not actually that, sorry. New. If you just opened SPSS, you should be able to do it. It should just pop up. I have too many things open. All right, so first we're going to go in and put in our Well, first let's read the example, because otherwise you're not going to know what I'm talking about. So let's answer part A. What is the dependent variable? Pain relief, yep. So how is that measured? Is it nominal, ordinal, or continuous? It's nominal. So we're seeing if there was pain relief or not within 30 minutes. So I know it says 30 minutes, which makes you think it's continuous, but you're just looking to see if yes or no, if there was relief. What is your IV? Treatment. So is your the new pain reliever or the placebo? So that is measured nominally, right. So what statistical test are we going to use if both the DV and the IV are measured nominally? The chi-square. The independent t-test has a continuous dependent variable. The chi-square has both either nominally or ordinally measured dependent variables and independent variables. Yeah. The paired t-test has a continuous DV and a paired nominal IV. So this will be a chi-square that we're going to run in this first question. So now we want to enter this data from the table into SPSS. So how in the world are we going to do that? First, we're going to make our variable names. So our dependent variable is pain relief. So I'm going to call it pain and label it as pain relief with the values of 1 equals pain relief and 2 equals no pain relief. And then I'll press OK. And then we're going to go make a second variable for our independent variable, which would be treatment. And the other thing you can do, if you want, is make this DV and make this IV. It will help you remember when you're putting it into that chi-square table thing, so you don't mess it up like I did. And then the label will be treatment provided or something like that, so you know what your topic is. And then the value will be 1 for the new pain reliever, or you can use 0. It's up to you. Just make sure you know which one you're using. They just have to be 2 different numbers. And then 2 will be a placebo. Okay. And I'm going to get rid of the decimal places because they annoy me, but you don't have to do that. Does everyone have that in their file so far? So the name, 2 variable names, labels so you know what you're talking about if you come back to it later, and the values here. Now if you want, you can scroll over and change the measure to nominal, since both of these are measured nominally. Now we're going to go to data view, and now you'll see at the top you have the pain and the treatment. So first, we know that there are a total of 20 people that received the new pain reliever. So that's the treatment. So we're going to say there's 20 people that received this. So we're going to go all ones in the second column down to the 20th row. So it should look something like that. Now 14 of these people that had the new pain reliever did have pain relief. So we said pain relief was 1, so 14 of the people should have a 1 in this first column. Now we should, after you do that, you should have 6 left that did not have pain relief with the new pain reliever. So we coded them as 2 in when we made the variable, so we'll put 2's there. So that's all of our people in the new pain reliever group. Yes? If you if you click this 1 to A button, it'll change it to the number. Either way is fine, but it just has it in whichever way makes the most sense to you. So if you click this, it just shows you whichever. So if that makes more sense to you, use it that way. If the numbers make more sense, use the numbers. I like the numbers because otherwise there's too many things happening. Okay, so now we have those first 20 individuals. Now we want to put the placebo group in. So they were in the treatment IV coded as 2 for me. So I'm going to put in 20 people that were placebo. So 20 people that have 2's. So it should be down to this row 40 then. Then the first 9 had pain relief. So that was 1. So we're going to put in 9 people here that have 1. So up to 29, row 29. Because remember, each row is 1 person. And then there were 11 people who had the placebo that did not have pain relief. So there'll be 2 for the rest of the individuals we have here. So that's what your data will look like. And when I ask you to put a screenshot of your data into your homework file, you're going to take a picture of this screen with, at least so I can see that you have the pain and the treatment with the 1's and the 2's, so that I know that you entered it this way and not some other way. Because if you enter the data wrong, everything else will be wrong. And if you don't show me the screenshot, I won't know that you entered everything wrong, so then you'll lose credit on everything instead of just this question. Okay, so now we have our data entered. We're going to go run the chi-square. So analyze, descriptive statistics, cross tabs. Which one goes in the row? Treatment provided, and no lies. I think, hold on. So we want it to look like our 2x2 table here when it comes out. So we want treatment to be the columns, and we want pain relief to be the rows. See, I get confused too. It's all right. You can play around and make sure it comes out the way you want it to look. You can run things more than once. It is totally okay. But since I ran that, I didn't check off the chi-square, so it didn't do that for me. And I did not check off the column percentages, so it didn't do that either. So I have to go back into those boxes and do that, and then press OK. And now it tells me I have 40 people, which is what we want, because in the question it says there's 40 participants. And then these numbers in these boxes here match with our 2x2 table on the paper, or on the computer if you are using that. But we found the chi-square value down here of 2.558, I think. Yep. There's 1 degree of freedom, and then the p-value is this sig value, this first one here. Now, because both our DV and IV had 2 categories, It also gives us this Fisher's exact test, which just calculates a p-value differently. So both of the p-values that are here show that there's no statistical difference, but if you report this p-value, if it's a 2 by 2 table, I will accept that as well. But normally you're just going to use this top one. So if you are confused, just use the top one. Did everyone's come out to look like this? Did you enter your data differently, maybe? Possibility. So check and see what you have if yours compares to what I have on there. What is your result? So it looks like here, document the total between 1 versus 9. So there should be 20. So it's 1 to the end. So you go back. What? And then
but I know we have a few days, so I'm like,
and then
I know that's true, but thank you, I appreciate it. I pulled through last time. Yeah, what? You would do it? Text me, you do it. And it's an asshole because she asked me about the class last week and I told her no, so then she purposely didn't go and tell you. So that's on her, that's not me.
What did you guys left us?
What was that you said? What was it here? Oh, yeah, no, and then I was like viewing all day, and then she texted me saying stuff, and I was like, well, actually. And then Jen was like, I just didn't go. She's like, I don't like sitting there.
It's boring. We have studying.
and then try to.
No.
So now try and have.
We'll start tomorrow.
Okay, see,
Did everyone else get the same thing I have with them? Okay. So then writing out the results is just the same as the format on the PowerPoint. But I will write the way I have it on my little fancy answer key and the way I have it on my the homework assignment answer key, which is hold on, let me open something to write it in so you can see it. Aha. Okay, so the percent reporting pain relief within 30 minutes was not statistically significantly higher, in those receiving the new pain reliever, 70%. So we know it's 70% because in our output, our output shows that there are 70% in this top box that used the new pain reliever and had pain relief, as compared to those receiving the placebo, which is 45.7%, because the number receiving the placebo that had pain relief was 45.0. Or 45%, since I didn't put any decimals in the first one. And then we put the weird X, but you can just put a normal X because it's easier. Squared. Then the degrees of freedom. So again, we look at that first line in the output. It's 1 equals the value for the chi-square, so the Pearson chi-square value is 2.558. And then the p-value. You can report the exact level or that it's greater than 0.05. So either that or p equals 0.110. Either way, it's fine. if this p-value were less than 0.05, then you would have to change this little symbol here. So just make sure you're aware of that if you're using the less than instead of just reporting the exact value. Does that make sense? Pretty easy, right up. So what else is on this? I think I have it up here. The next page is a table that is already done, and there are both independent t-tests and chi-squares. So what you're going to do is first answer how many inferential statistical tests there are. So look through the table and write down what you think, and then tell me what you think, and I'll tell you if it's right or not. So remember, inferential statistics are independent t-test, paired t-test, chi-square. That's all and the McNamara, but that's all we've learned so far. Descriptive statistics are the mean and standard deviation, or number and percent. So this is asking how many inferential statistics tests. 7. So how did you find that out?
By looking at the p-value.
Yeah. So for each test that's calculated, you'll look at the p-values, and there's always a p-value if there was a test done. So here there's 7. So this next part is asking you to identify the level of measurement of the dependent variables, which are presented along the left side of this table. The IV is marital status, which is across the top of the table. So you're going to look through and see what level of measurement, nominal, ordinal, or continuous, and write that here. And then based on that, you're going to determine if it was an independent t-test or a chi-square in this column. So that's the next step. So I'll let you do that, and then we'll go over that part. If you've already done it, you can keep going. Yeah.
Can you go back to the screen line on the Word document when you were typing in?
Oh, yeah.
Okay.
Yep, no problem. So what's the level of measurement for age? Anyone? What do you think? Based on the table, so we see the variable here. Variables are listed here, and then these are either mean and standard deviation or number and percent. So what do you think age is based on what you see here? It's continuous. So if it was ordinal, it would have categories underneath the main heading. It would either be, if there's categories, it's either nominal or ordinal, usually. So this is measured age in years. So the mean and standard deviation are listed here. So since that's measured continuously, what statistical test would you use? Yep, an independent t-test because the DV is continuous and the IV is nominal. So remember, the IV is marital status, which is nominal, married, or not married. And you can't be in both groups at the same time, so it's not paired. What about race? What is that level of measurement? I guess I can make this bigger so you can see it better.
Nominal.
Nominal, yay! So what's the test going to be for that? Chi-square, yeah! Since both the DV and IV are measured nominally, it's a chi-square. Number of prenatal care visits. Continuous. What's the test?
T-test.
Independent t-test, yeah! Completed weeks of gestation. Continuous, yep. So it's a number, it's a range from 0 to probably like 45, as long as I've heard. So it's a range of values, and it can fall anywhere there, so it's continuous. Statistical test.
T-test.
T-test, yeah, independent t-test. Method of delivery.
Nominal.
Nominal, so since there's 3 categories and there's not one that's inherently better than another one, it's nominal. So what test would be used then?
Chi-square.
Chi-square! So exciting! Yeah! What about the level of measurement for attendant at delivery?
Nominal.
Nominal. So could be a doctor with an MD, a doctor with a DO, or a midwife. So not one isn't inherently better than the other, so nominal as test would be chi-square. Gender of newborn. Level. Nominal. Test.
Chi-square.
Yay! Okay, so letter C here. Looking at that table overall, not the one that we just went through together, but this top table here. If you're going to create an intervention to help pregnant women get more prenatal care, who would you want to consider when recruiting for your intervention? So if we look at the prenatal care visit row, we see that married mothers had an average of 12.3 visits and a standard deviation of 3.8, and unmarried mothers had an average of 11 with a standard deviation of 4.3. So that means the range of values for not unmarried mothers is larger, so more of them got fewer prenatal care appointments than married women. So I would recommend going with unmarried women as opposed to married women based on that. And the p-value for the difference in the independent t-test was 0.000, which means it's less than 0.05, which means there is a statistically significant difference between the number of prenatal care visits for married and non-married women, which means since the non-married mothers had fewer appointments, that's who we would want to target to increase prenatal care appointments. Does that make sense? Kind of? Okay. So since the p-value is less than 0.05, it means there's a statistical significant difference between the number of prenatal care visits of married compared to not married mothers. Since the not married value is lower, if we're trying to create a program to increase care for prenatal care, we want to target the people that are getting less care now so that they can get more care.
Why did not marry?
So we would target the non-married women, in this example at least. All right, now's the fun part that I'm going to let you do on your own, and then we'll talk about together. So, if you go on to T2L and go to Module 8, the in-class exercise, this dig activity file, in the SPSS file, if you open that, that's what I'm going to have you use for the rest of the assignment. Not assignment, the class, whatever, practice. We'll do the first one together. So we'll do the table and part A together. That way you get the idea of what I'm looking for at least. So let me know when everyone's opened that up. We can start going through this table. So variable type, age. Based on this table, what do you think age is going to be? Nominal, ordinal, or continuous? Continuous because it's measured in years, so that means there's a range of values. What about gender?
Nominal.
Nominal. Serum creatinine level? Nominal. Activity limitations? Nominal. So there's not one, well, technically having none is better than the rest, but if you rearrange the order of these in a response option, it wouldn't make a difference. So there's no order to them, so it's nominal. What about heart rate? Continuous. And then myocardial infarction or MI status? Nominal. Yep. So you have, I believe there's a question like this on your homework, so lots of practice. By the end of the semester, you're going to hate answering that question, but that's okay. It's going to help you determine which test you need to use. That's why I make you do it. So for this first one, we want to see if serum creatinine levels differ by age. So what is our dependent variable here?
Serum creatinine.
Nope, it's age. So we want to put age, and its level of measurement, which we set up here, was continuous. Then the IV is serum creatinine level, which is measured nominally. And since I'm asking you to report the categories, what are the categories of serum creatinine? Normal and abnormal. So when I'm asking for the categories, it's what is these, the categories in the coding scheme box. That's what I'm looking for you to put there. Does that make sense? Okay, so based on the DV and IV, what test should we use? Independent t-test, because the DV is continuous and the IV is nominal. So now we're going to actually calculate that using SPSS. So make sure you have the right file open. The dig underscore activity file. The other one was about the face study. So it has that data in it if you want to do something with it. So we have this open. We're going to just briefly look at what our data says so that we make sure that we know what it's saying to us. So first we have ID. That's just numbers so that we know who filled out which survey in there. So we collected surveys from, I don't know, however many people are here. A lot. And this first ID refers to the first survey that we put in. And we have that survey, the actual survey, printed out with the number 1 on it. So if we made some mistake in coding when we put stuff into our database, we can go back to that original, the filled out paper copy of the survey and change it. That's why there's always an ID variable here. Okay, so the first person, they're 55, they are gender 2. I don't know what that means, so Maybe let's go to variable view and look at what gender. So they're female. Okay. Their creatinine level is 2. That is abnormal based on that code book that I put in the thing, or you can go and look at the data variable view and see. And then activity limits, there are 3, which I think is they have both past and present limitations. Their heart rate's 52, and they have not had a previous MI. So that's what that first line's telling us. And then, wow, we got a lot of people here. Okay, we're not going to look at all of them. You just want to look at maybe 1 or 2 people just to make sure you know what the data actually is saying. Okay, so now we're doing an independent t-test. So how do we do that? What am I going to go to? Analyze. For an independent t-test?
Compare means.
Yep. Independent samples t-test. I know we've been doing chi-squares. You don't want to do this one anymore, but you have to. Okay, so what are our test variable? So what is our DV? Age. And then what is our IV, or the grouping variable? Previous MI, right? So that's this last one here. And remember, we have to go in to define our groups if there's the question marks there. So 0 is not having an MI, and 1 is having one. And then, so we enter that in and press continue, and then okay. All right, so what does this mean? Oh, all the numbers. So we have the mean values for age for those who did not have an MI and those who did, as well as the standard deviation. And then down here, remember, we want to look at this first sig value. If this is greater than 0.05, we look at the top column. If it's less than 0.05, we look at the bottom column, row, not column, sorry. If it's greater than 0.05, we look at the top row. If it's less than 0.05, we look at the bottom row. So since it's greater than, we look at this top row. Our t value is negative 0.539. We have 2020 degrees of freedom, and the p-value is 0.59. What does that mean? Is there a statistically significant difference or not? What do you think? If the p-value is 0.590, is there a statistical difference or no? So since this is greater than 0.05, there's no significant difference between age. There's no significant difference in age between those who have had an MI and those who have not had an MI in our sample. So to write that up, we would say equal variances assumed, because we're using the top row. That says equal variances assumed. So since we said this is above 0.05, the first sig, we use the top row. If it was less than 0.05, we use the bottom row and say equal variances not assumed. An independent t-test found that age was not, I'm capitalizing this for effect, but you don't need to do that, significantly different between those with a normal serum creatinine level. Then we're going to put the mean values, which we find in this top box here. So the mean for those with a with a normal level, what is that? Oh wait, lies. What am I talking about? I have a different example, sorry. that age was not significantly different with those with an MI. How many did not have an MI? Or did have an MI? 63.49 is the mean. And then our SD is 11.06. And those with those who did not have previous MI, and then we put the mean, 63.21, which is in this top row, and the standard deviation is 10.99. Then we put in our statistics, so T, and in parentheses we put which value from this table. Right after the T, we put the parentheses with the degrees of freedom. So here will be 2020, which is our degrees of freedom. And then our T value is equal to negative 0.539, so that comes next. And then we put our P value, so P equals 0.590. Or you can put P is greater than 0.05. Does that make sense to everyone? Do you need me to make this part bigger? I can do that. So now there are 3 more questions like similar to that that you're going to do the same thing. Identify the DV, its level of measurement, identify the IV, its level of measurement, identify which test you would use. In this, it's going to be either an independent or a chi-square. Independent t-test or a chi-square. And then you're going to run it in SPSS using that data set and then make a write-up. So I have 3 more examples. So if you want a lot of practice, you can do all 3. But that's up to you. How are you feeling? You want to do all 3? You just want to do 1?
We can do one more.
1 more? Okay, so we'll do B then. Does serum creatinine statistically differ by gender? So that's B. So what is our dependent variable? Yes.
Yeah.
What's the independent variable?
Serum creatinine.
Yep. And then how are they both measured? They're both measured nominally. Oh, we're going to do 3 because the next one might get confusing. We're going to do up to C. Sorry, guys. So what test were we going to use since they're both measured nominally?
Chi-square.
Chi-square. So we're going to go back to our data set, analyze, then what? Descriptives, crosstabs. So what goes in the rows? The DV, which is gender, and the columns is the IV, which is serum, whatever, creatinine, whatever. Then we go to statistics. It's getting late, guys. I don't like this time change. I want to be in bed. Just saying. So check off chi-square, continue, go to cells, check off column, continue, then okay. And then we get this beauty. So based on this other write-up, what can we say according to these results? Okay, that's one way to write it. I like my other way that I have in my answer key better. So another way to say it is a chi-square test found that serum creatinine levels were not significantly different by gender. And then you put the little X symbol with the 2. Then we put what? What comes in the parentheses?
1.
1 is the degrees of freedom, so that's found in this top row. Then what value comes next?
Yes.
1.049 is our chi-square value, so that's this value here. And then we have our p-value, so we can put p equals
Okay.
306. Perfect. So this is a little bit easier than that other one to write up.
Yeah.
So either way is fine. And again, since there were 2 categories for both of these, you could use this 0.320 as your p-value as well. Either one would be acceptable. Okay, one more. Do activity limitations significantly differ by MI status? What's the dependent variable? MI status. How is that measured?
Married or not?
Yep, so it's nominal, yes or no, are the categories. What's the IV?
Activity limitation?
Yep, activity limitations, and how is that measured?
Nominal?
Nominally, and what are the categories for this one?
Present, past,
Yes, so the categories are none, past, present, and both past and present. So based on that information, which test are we going to use?
Chi-square?
Chi-square! Woo! So we're going to go back to analyze descriptive statistics, crosstabs. I'm just going to hit reset because it puts everything back where it's supposed to be, and we can start over. So what goes in the rows?
MI status.
MI status. And the columns?
Limitation.
Activity limitations, yep. Then we go to statistics, and when it is ready to load, we click chi-square in the top. Oh no! And then we press continue, then we press cells, and column, and continue. And then we press OK. So here you can see that there's now 4 columns with the 4 different categories of activity limitations. So remember way back in the PowerPoint presentation at the beginning when we talked about the trend either increasing or decreasing as this the independent variable changes? So here you can see there's not much, it doesn't look like there's much difference in MI status, except if they only had past limitations, 38% of them did not have an MI. Everything else is under 33-ish%. And then no activity limitations, but having an MI is the highest category in the having an MI status. So what are we going to include in our write-up here? A chi-square test found that activity limitations were these significantly different among the different levels or not, based on our chi-square result. So we look at the p-value and it's above 0.05, so there's no significant difference. So they were not were not significantly different by MI status, comma, x square. What goes in this container? 3, because it's the degrees of freedom. So since there are more categories, the degrees of freedom is higher. And then what comes next?
2.834.
Yep. And then our p-value is 0.418. So here you can see, since it's not 2 categories by 2 categories, it doesn't even produce that Fisher's exact test. It just has this top row here. So if we look at the other one, it had that extra row with the Fisher's exact values, but since this has more categories, it doesn't have that. Any questions about this? Was this helpful?
Yes.
Okay, so let me just pull up your homework real quick so I can talk you through it a little bit. So the work.sav file in Module 8 is what you'll be using for the homework, part of the homework. So if you open homework 8, this is what we got. There are some multiple choice questions. There's 5 of them. Then we have some descriptive statistic information. So you're going to go through the code book and label these as nominal, ordinal, or continuous. Then, please don't hate me, I'm going to make you complete this table. So this is very similar to what you did for the homework 4. So I'm going to get that video of how to walk through that and do that up as soon as possible by Wednesday so that you can do this. But this is not due until the 21st, so you have some time. But because so many people struggled with that, I want to give you some more practice doing this part because you're going to have to do it the rest of the semester. So. Lower stakes when it's involved in an assignment with other questions too. So you're going to split the file. You don't need to have the total characteristics. You only need to have the statistics from part-time workers and full-time workers. If you look at the PDF file in your feedback for homework 4, I wrote on them in the table and made a lot of comments and things. So if you did struggle, go and look at that to get extra feedback on stuff. But I did make it's already APA format and there's already a title, so you don't have to worry about those. Make sure you put the number and % of people in these 2 categories, and then you're going to do either the mean and standard deviation or the number and % for these other characteristics for both part-time and full-time. Then you're going to write a summary of the table. So we did this a little in the beginning of the semester. What I'm looking for here is just a topic sentence saying, Table 1 shows the descriptive characteristics of blah, 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 something like that. So I am introduced to the table. Pretend it's not me reading it. Pretend you're publishing this somewhere, and you have to tell them what to look at. And then you're going to summarize kind of what you have up here without writing every single number. So maybe say, I don't know if this is true or not, but maybe there were 50% of part-time workers were female and 27% of full-time workers were female. That would be summarizing the variable gender without reporting every single number you have up here. Does that make sense? So you don't have to say every number, just a brief highlights of maybe which category has the most individuals or which has the least for the nominal and ordinal variables. For age, you can list the mean and standard deviation. That's fine. I'll be pretty lenient on this. I just want to get you thinking about how to write out a summary. So I'll give you lots of feedback when you do write it. So just do your best. Don't make it too long either because short's good. Okay. Then part 3, this is using the file up here, the same file that you did those descriptives with, to answer these 3 questions, which are shockingly similar to the ones we did today in class. So it's a different data set, so you won't be able to just copy the questions we did in class, but it is the same idea. Identify the DV, the IV, their level of measurement, and the categories if it's nominal or ordinal, the test to use. So here, you're either going to be doing an independent t-test, a paired t-test, or a chi-square. And then you'll do your write-up just like we were doing in this Word document over here. So that's all I'm looking for. You don't have to include your SPSS output at all for this assignment, actually. Does that work for everyone?
Mm-hmm.
I did not list point values, so I'll have to do that. But otherwise, you have 2 weeks to work on that one. You have a week to work on homework 7. If you have questions, I'll be here. I'll wait for you. But that's all I've got for you for tonight. So enjoy the darkness now that we end
Seriously.
in the middle of the night, apparently.